Everyone, welcome to the ST Yao High School Science Award 2025 Science Talk, Serendipity in Science. I'm Carmen Wong. I'm the member of the Hong Kong Young Academy of Science. It is my honor to be the moderator of the online science talk today, which is organized jointly by the Hong Kong Academy of Sciences, ASHK, 香港科學院, Yale Mathematical Sciences Center of Tsinghua University, YMSC 清華大學優成同數學科學中心, the Institute of Mathematical Sciences of Chinese University of Hong Kong, IMS 數學科學研究所, and the Hong Kong Young Academy of Sciences, YSHK 香港青年科學院. Yale Prize is a research-based competition emphasizing on innovation, originality, creativity, and persistence in research activities. It has 6 subject categories, which are mathematics, physics, biology, chemistry, computer science, economic and financial modeling. Yale Prize Asia covers Hong Kong and the entire Asian region outside mainland China. Before we start, we will have a review of 2025 Yale Prize Asia. We will have an introduction, pre-recorded opening remark by Professor Dennis Low, the president of the Hong Kong Academy of Sciences.
Professor Shing-Tung, Professor Cheng, Professor Mei-Po, Professor Chien, Professor Carmen, students and everyone online, good morning. Welcome to this Science Talk, a key event of the 2025 ST Yao High School Science Award Asia. First, I'd like to express our gratitude to Professor Yao, the founder of this award. His vision and unwavering dedication to nurturing young scientific minds have been a driving force behind this platform. His belief in fostering curiosity and innovation amongst the next generation has inspired many students to follow his path in science. I would also like to extend our thanks to the Innovation Technology Industry Bureau, ITIB, and the Innovation Technology Commission, ITC, of the Hong Kong SAR government. Their generous funding and support have made this program a reality. ITC's commitment to advancing innovation and technology in education plays a crucial role in shaping the future of science and research in Hong Kong. Thanks to their support, young scientists are empowered to explore new possibilities and contribute meaningfully to a global scientific community. We have a fantastic lineup today. The newly elected members of our Academy, Professor KWAN and Professor Ng, are here to share their career journeys, personal experiences, and invaluable perspectives. The contribution to science are truly remarkable, and the words of wisdom will undoubtedly inspire all of us, especially youngsters here today. We also welcome the 2025 Physics Silver Prize winners from the Independent School Foundation Academy, who discussed their research journey and experience participating in the competition, demonstrating how curiosity and perseverance leads to success. The 2025 cohort has once again exceeded expectation and set new records. An incredible 509 teams from 24 regions participated in the competition. It was a tough selection process, narrowing down to 41 teams who defended their works in the Asia final. In the end, a total of 25 prizes were awarded, recognizing the brilliance and hard work of these young scientists. In December, 11 gold and silver winning teams represented Asia at the St. Yao High School Science Award finale at Tsinghua University, competing with teams from the Chinese mainland and North America. Asian teams have won 2 bronze awards and 5 honorable mentions in the finale. Congratulations to all the winners. As we celebrate the achievement of this year's participants, I want to take a moment to acknowledge everyone who has made this possible. In addition to the students and the supervisors, 34 esteemed professors generously contributed their time and expertise as members of the assessment panels. Their dedication and hard work were instrumental in the success of 2025 YHSA Asia. Now today, this isn't just about looking back at a great year. It's about looking forward. Science is always changing and needs people who weren't afraid to ask why. I hope the stories and insights shared today will inspire each of you to pursue your scientific aspirations and contribute to addressing the challenges of tomorrow. Thank you and enjoy the talks.
Thank you, Professor Lo, for the introduction, and it's very encouraging. And we are also very thrilled to have Professor Shing-Tung, Secretary for Innovation, Technology and Industry. He has a pre-recorded message for us.
Professor Yao, Professor Lo, Professor KWAN, Professor Mei, distinguished speakers and guests, fellow students, ladies and gentlemen, good morning. It is my pleasure to join you once again at the online science talk of the St. Yao High School Science Award Asia. As we welcome the Year of the Horse, may I extend my warmest wishes to you and your family for good health, happiness, and abundant success. The theme of today's talk, Serendipity in Science, captures a truth that every scientist eventually discovers. Many see serendipity as mere luck, but in research, it is far more than that. As the famous saying reminds us, chance favors only the prepared man. Serendipity only comes when a scientist is well prepared to notice and investigate an abnormality and has the persistence to follow where the data leads. I'm sure our distinguished speakers today will show how rigor, patience, and an open mind can transform a happy accident into a scientific breakthrough. This year marks the 7th year of YHSA Asia. Since 2019, it has attracted more than 2,230 submissions from 33 regions and countries. Each entry represents a young man daring to push the boundaries of knowledge. I congratulate all awardees, especially our Hong Kong students, on your outstanding achievements. Nurturing talent lies at the heart of Hong Kong's innovation and technology development. Through the Inno-Hong Kong research clusters and the RISC+ scheme, we are accelerating the transformation of R&D outcome into real-world impact. We have also launched the Frontier Technology Research Support Scheme to attract world-class researchers and their teams to Hong Kong, and the Research Talent Hub to fund eligible enterprises and institutions in recruiting STEM graduates from both local and overseas. All these initiatives share a single purpose: to build an ecosystem in Hong Kong where young innovators like you can turn ideas into impact and curiosity into discovery. I would like to take this opportunity to express my deepest gratitude to Professor Yao, founder of this award, whose vision continues to inspire generations of young scientists. My sincere thanks also go to the organizers, the Hong Kong Academy of Sciences, the Yale Mathematical Sciences Center of Tsinghua University, and the Institute of Mathematical Science of CUHK for creating this world-class platform that empowers young scientific talent across Asia. As I close, I wish the online talk today a great success. May the insights you gain today guide you towards your own serendipitous discoveries in the world of science. Thank you.
Thank you, Professor Sun, for the warm and encouraging message. And let's get to the core. Today, ASHK invited two international renowned scientists to share their illustrative careers with personal stories and experience in research. They are Professor Mei-Po and Professor Siew. In addition, 2025 Yale Prize winners Terry Wang, Simon Chung, and Michael Huang will also share their competition experience. Now, I would first like to invite Professor Mei-Po to share with us her path of science research. She has a long list of accolades, so I have to read it out because I can't memorize such a long list. Professor Guan is a member of the Hong Kong Academy of Sciences, Choh-Ming Lee Professor of Geography and Resource Management, head of Chung College, and director of the Institute of Space and Earth Information Science at the Chinese University of Hong Kong. Professor Guan has made groundbreaking contributions to research on environmental health, human mobility, transport and health issues in the city, and geographic information science. He discovered the uncertain geographic context problem and the neighborhood effect averaging problem. She's a leading researcher in deploying real-time GPS tracking and mobile sensing to collect individual level data in environmental health research. Please welcome Professor Guan.
Hello, hey, can everybody hear me?
Yes.
Okay, great. Yeah. So I am very grateful for the invitation and also very grateful for Professor Yao Xing-Tung for actually creating all these wonderful awards and also more importantly, encouraging the younger people to participate. So I would like to share my own career path and also hopefully that, that can have some encouragement to the future generation. So I'll use about 20 minutes to share and using some slides. And by the way, my name is Mei-Po and I'm the head of Chung College and also, like Choh-Ming Lee Professor of Geography and Resource Management and Director of ISCIS at CUHK. So, well, something about me. I mean, this talk actually, to prepare this talk actually make me think about, my career path and when I was young, And then I think and I was born and raised in Hong Kong. So I'm really a local. And also I went to the Chinese University of Hong Kong and Chung College, as you can see in the picture. The Chung College, the CUHK buses, like the shuttle bus, actually look the same, when I was graduating a long time ago. And then I was graduated with a degree in geography at CUHK. And also I went off to the United States to study my master's degree and also my PhD at UCLA and UC Santa Barbara. And then I worked there for about, 30 years before I came back to Hong Kong, going back to my alma mater and then my CUHK and Chung College and become a head of the. So I think that, when I think about my career and So in Hong Kong, education in the high school education then is very, very divided into the humanities and the STEM education, very clear cut. Yeah, so very early on. So, and then the problem of me is that I like all of them. I am very good into, this is a mathematic competitions, and I wish that there was a Yao Award. I was very good at mathematics, and then in math, I'm always ahead of my teachers. And it was, like my favorite subject. And physics and chemistry, science subject, I was number one in all my classes. And however, I also like the humanities, like the Chinese language. And then the literature, history, philosophy, I like them all. And I think I'm fortunate that I was good at all of them. So it was a pretty I think that, I can pretty much handle all of them. I never ranked second in any subjects and any of the classes grades. But that also posed a very big problem to me is that what do I like? So it's very difficult for me to decide on what do I study. But in Hong Kong, the education in high school, that is boxes, that we cannot really call cross. And then, so they usually label you as some kind of subjects and then fix you on that. So, and then that, actually has a big implication for, in the future, because I am not be able to fix in a box. So I always think about, how, because I think that all those are, are complementary, and then we can actually cross a boundary. So why do I want to talk about this is because in the future, actually, this is one of my major contribution to the field, to my discipline. And then one of my paradigm shifting, contribution to my field is actually is crossing the boundary. When people ask me what is the future of geography, I propose hybrid geographies that is crossing the arts and humanities and the social, and then also the scientific and physical, geography, and then crossing the boundary to propose the hybrid. And then that actually changed, the whole field. And that is why later on, you can see that I'm getting many awards. And so I think that is, like some of my background actually contribute to the future, like a career path and academia and thinking of me. So, and then like many high school students, I began without a clear passion or particular interest. I like them all, but I also, the drawback of this is that I also don't know what I really, really want to focus on. The soul searching is actually, is a long process, and I would like to explore different subjects, activities, and then, so in that time, actually medicine, of course, is the major, and my teacher said, why don't you go into it? It's a very prestigious and extremely important subject. Only very few elite, can go to. And also, of course, the business school, and also is a very popular. And I'm not saying that those are not good. Those are extremely good, especially these days, my relatives and went to see the doctors, and they're so helpful. And I think that this is really, really important subject. However, but not, they can only admit, few people, and also not everybody's passion is there. So I think that, being so rebellious at that age, for me, then I want to do something, different. And I always think that, for example, I do something very different in matriculation examination. And when I'm going to take the Chinese literature exam, that I will study English literature. And I just want to show that, I'm different, at that age. By the way, it's only at that age. Now I'm, of course not. So I just think that, is there any other path, other than, what people are usually do? So I went into Chongqing College and then CUHK, again, without too much determination about what I want to study. And then in the beginning, I want to study Chinese literature and also mathematics. So I think it's the very different way. So I'm not having a very big focus. But good that, the college system at CUHK really provide us with a very general, education. And, like the first year is actually very open. So I was, like people promoting, oh, we need to be having, like both the virtuous and talent master, and then we need to have, the good conduct and also have good talent and also have the spiritual. And the general education made me think independently, seek the truth, and be reasonable, ethical, and legal. So, and also teach us how to face and solve problems. So I think that all this foundation of the GE, of the general education, actually provide me with a much broader perspective of my future career. So I'm really grateful to that. So actually, that's probably one of the big reasons why when I came back to CUHK, I became the head of the Chung College. And so my soul searching, also like with my quest for, like social justice and social inequality. At that time, I also really be thinking about the wealthy people and the poor people, and then their lives are so different, what they experience. And I'm thinking that can I do something to contribute, to, like to the society and also our country, and of course, eventually the world. And thinking about geographically, looking from several hundred meters, like in a plane, or we can actually see, like the wealthy people and the poor people may, live very differently. But the major turning point is when I was joining Chung-Chi College exchange students, program to go to Japan for 1 year. And then I never really traveled outside Hong Kong at that time. So suddenly I went to ICU in Tokyo and we stay in, in the Japanese culture. Actually, it's very different than the Chinese culture, even though there is all Asian. So at that time, I was exposed to different culture. And I was also, some very good, professors took me to around Japan and looking into how they build the harbor, how they plan a city. So actually that really is an eye-opening. And I find, I found my vision and love, in the urban planning subject. So I began to looking into geography. So I mean, combining my different strengths in language and science, conventional expectation, challenging the conventional expectation, and I decided to study geography to protect the environment, the well-being of the people. However, my trajectory doesn't fit in one box. Again, I think that like I went to the U.S. to study urban planning and then geographic information science, and this is a pretty like a new subject for me, and I'll explain why they are not conventional geography that you would think. Again, for my trajectory of my career, and UCLA at that time is the top 3 urban planning school in the world. And when the geography, UCSB, GIS science is the top, is the #1 in the world. So I was offered, a full scholarship at MIT for studying, like GIS. And then I think that UC Santa Barbara is #1. And at that time on that particular subject, so I think that, like, so again, I was not feeding in anybody's expectation and thinking about different things. So my study is focusing on facing the grand challenges in the globally. For example, climate change and global warming, they're big issues and that has many consequences. For example, in Hong Kong, we face, the severe, like black rain and of the decades, and then hurricanes and heavy rains in all over the places in Asia, also in the world. And then also in the polar center, polar, and then there's also different kind of evidence of global climate change. And mental health crisis is also, worsened, in the world, especially after COVID-19. And then the mental health crisis also worsened in Hong Kong. So as we face these global challenges and how thematic, problems, and how do we look into the vast road ahead of the young people, and I want to share some of my thoughts with both with my academic, like using my academic career, academic, like research, and also my personal, thinking. So the traditional geography focus on the forms and patterns of the environment and human beings, and that is something that we want to revolutionize. This is like a map, right? I mean, everybody think about geography as a map, but actually it's not true. It's there's more to it than that. Yeah. So, for example, I'm also the director of the Institute of Space and Earth Information Science, and we do quite a lot of stuff. Yeah. For example, remote sensing, we also launched a satellite recently, and then also, we have a study in carbon, emissions, and that is related to climate change. And then we also, use UAV, and then that is looking into the low altitude, economy, and also the sustainable development goals. So I think that geography is much broader than what people will think. We use geospatial AI and build AI models, and then they're looking into the virtual environment. So all this, are, also looking into the ground or Earth observation, and then we also look into human behavior. So then think about the daily mobility of environmental exposure. My research also touch using all this, new technology and AI models, and we also think about the daily mobility and environmental exposure. For example, all the way of how do people move around and in a daily life. And the environmental exposure, we can categorize the environment to the lat long and to a very refined scale. And then temporally, we can do it in every 1 second. And not only if we can categorize, the environmental exposure to that real, and we also track people of the daily trajectory. So this is, the daily life of a Muslim woman in the United States. And then the color code is on how their feelings. And then, so how do we get the feelings and emotion is also, and perception of the environment is also very important. And of course, I don't have time to explain, what is my major revolution, in the field, the uncertain geographic context problem that I articulated in 2021 that become one of my most highly cited papers. But this is using different kinds of technology, motion sensors, and, articulating a major problem that is, then if we look into the geographic context incorrectly, then actually it's making, invalidating a lot of the environmental research result. That means that you can actually throw away a lot of the papers because they are in error. Yeah. So, and then the neighborhood effect averaging problem is looking into human mobilities. We can summarize the people moving around, and then also that is, important for average, that exposure. Then again, this is also talking about you can actually throw away a lot of the neighborhood effect, papers, because they also identify, the mobility and neighborhood effect incorrectly. So, and then I think I have to be faster. So then I will be, talking about my research in a more quicker way. Then using remote sensing technology, we can see car movement. We can identify every single car in all the streets in Hong Kong, and of course globally, because we are seeing, the world, that all this from, from the sky, so happen. Yeah. So we can do prediction by training the pre-trained AI model. We can do this, and then we can also look into the gas, carbon neutrality, because all the government are talking about, carbon neutrality 2030, 2060, but however 2050 in Hong Kong, but however nobody actually have measurements. Then we actually using carbon satellite also to the very precise, much more precise resolution. Then we can actually do, carbon neutrality estimation and looking into the source identification. This is the very big project funded by ITC recently, and this is, also, promoted by the government. So, and then also we can looking into the carbon, things. For flood monitoring and emergency response, yeah. Yeah, sorry, this is in Cantonese, yeah, but what it's saying is that we can use remote sensing data to look into flood monitoring and emergency response, yeah. Yeah, so I think that so this is we already launched 2 satellites from the ISCIS from our research institute, and one is about the youth like satellite, and this is experimental. It's already launched in 2024, and it is decided and developed and also made by our like research institute, and also and then also the data come back will go to the for research of people. So the research, and then the just this February, like the CUHK satellite, is the first, like AI, model incorporating deep sea, into the satellite. So the calculation actually is in the sky, in orbit, AI model that is actually the world's, first one. Yeah. So serving, sustainability. So all this scientific, development is also feeding into our, like getting into the data, feeding into different kind of application. So we also have the aerospace science informatics, and double major program at CUHK. And then we also open, we have some promotion to the high school students to provide them with a dream. I always think that not everybody can go to, like the rocket on and go to, but we can study the information from the like aerial space. So this is something that a double major at CUHK. So my career path, I get quite a lot of honors and and rank quite like a lot of difference, rank high in my field around the world. And then also recently, I got the World Academy of Sciences and also the Hong Kong Academy of Sciences. And then a Lifetime Achievement Award, and also contributing to entrepreneurship. Yeah. And then the United Nations visited us, like because we also, like Southeast Asia and Asia, and then we also contribute, use our, my research also contribute quite a lot to the United Nations research agenda, and also especially in emergency response and sustainability. And so all this, like I think about the quality, about, like the key thing is that from my career is to think and solve problem independently. I think this is a very important. And the like the fact that I cross different fields, and then also not just, combining different things in partially, but actually went to the top of each field, but be able to integrate them, I think is also a very important thing. For example, remote sensing, doing the AI model in orbit, I think we are the number one in the world, world class and research, at least, the tops. Yeah. And also also in the environmental research field. And the other way is that I always concerned about the community and also the society. And then, of course, technically it needs to be, important adaptability, and also have a cross-cultural awareness. So many of the, like think that, oh, yeah, we got many awards and it is very easy. But actually, everybody has their own big era. As a woman of color working in the United States, actually not everything is very easy. And then also that face, a lot of discrimination. So that's why I keep working harder and harder and persistent. And then my series get longer and longer. So that means that, I realize that, like I cannot think about and ask for people treat me fairly, but this is something that we must be striving for the future generation. So subconsciously that people may have prejudice, but I would think that, like, for example, as a woman scientist, then this is very difficult to because there are very few of us, people. I mean, it's not explicit, but people subconsciously may think that, oh, men are, they're all, all around. So they may be not very accustomed to. I think through education and awareness, and I think that we need to be, in school, curricula, we need to be promoting equal opportunity for all, regardless of race, gender, and ethnicity and other characteristics. We need to cultivate empathy and understanding, encouraging through promoting cross the dialogue, diversity training program, creating space for open dialogue, about biases and discrimination. Some of them we may not even be aware of, and being always kinder than necessary. So in conclusion, so I would like to think about everybody will face their own big era. I think that always people, of our generation would be thinking, oh, we are facing so many difficulties. And so our, this generation is not easy and that kind of thing. However, I would like to propose that actually everybody in the past, in the future, would face their own big era, and we all face our own big grand challenges, and we need to be persistent. I will always think that we don't need a brilliant person to do good research, but need a persistent person. We do not want to compare with others. Always be kinder than necessary and embrace the difference. And my last words, is that, just like our Chung College board member, board chair said, we need to, be good, in physical and also in, and physical activities and also in our studies. And then we need to put ethics and also talent together, and the spiritually we need to be calm. And as the first head of the Chung College, and I want to inspire and motivate everybody to realize that in infinite possibilities, so everybody get a chance. And then also lastly, this is our research institute in at night. So I welcome you to come and visit us and explore the infinite possibilities. And thank you.
Thank you so much, Professor Guan, for the engaging talk. And next, we will have a sharing from Professor Siew about her inspiring career. Professor Ng is a member of the Hong Kong Academy of Sciences, Croucher Professor in Medical Sciences, and Associate Dean of Research of the Faculty of Medicine at the Chinese University of Hong Kong. She is at the forefront of epidemiology research on inflammatory bowel disease and the role of gut microbiota in health and disease. She has discovered novel gut microbiome signatures and transformed such signatures into clinically applicable non-invasive tests for early diagnosis of colorectal cancer, inflammatory bowel disease, and neurodevelopmental disorders in children. Let's welcome Professor M, please.
Thank you very much, Dr. Wong. I'm really inspired by Professor Yao's vision to nurture the next generation, and I hope to share with you my very humble journey through my scientific journey. We all wear many hats every day, and I wear 3 hats. The first hat is as a doctor and a professor at the Chinese Institute of Hong Kong. I'm a gastroenterologist and I see patients. The second hat is as a scientist and teacher of students in my laboratory. And the third hat is recently I've co-founded 2 biotech companies in this area. The first lesson I've learned in life is do not what you like only, but what you love. And exactly, I think passion drives scientific innovation. Let me tell you about my family. My great-grandfather came from Xiamen and migrated to Malaysia. When he was about 12, this is my grandfather. His father died, so he worked as a shopkeeper. He made only about $3 at that time. Half a dollar he gave to his mother. The other 2.5, basically, he used to feed himself. When my grandfather was 20, he met my grandmother, so they got married. And they had 7 children, 6 boys and 1 girl. That girl was actually my mother. So during those times, my mother never had the opportunity to higher education. So she had one dream, and that dream is to give her daughter the education she never did have. Actually, my grandfather was amazing. He opened an antique shop, and when he was 90 years old, he was still guiding the top front of the shop. And he used to cycle to bank in checks at the age of 90. They were married for 60 years, and this was them actually. And although sadly, my grandfather passed away when he was in his 90s a couple of years ago, the one lesson I learned is that as any scientist, as any person, success is more than reaching our goals. It's really living our values. And I think try not to be just a person of success, but one of value, the value of science, the impact that you can create in life. And I think this is a value I take away from my family. In my early years, I love watching the stars. I always think, there are so many stars that we don't have names for, and what are they? Who are they? What do they do? And this you will come and see resonate with my research later on in life. The other thing I love doing is solving these little dots that 1 to 20, and you see the amazing figure that appear. And I think solving problems and curiosity drives research later in life. This was me, 1982, when I graduated from kindergarten. Actually, my mother said I've already read all the encyclopedias in my grandfather's house, although I have no idea what they were. I just look at the pictures. But one of the things was that I always wonder, scientific discovery, is it by chance or is it that you have to work hard? And my mom then said, oh, you finished reading all these books. You must be born for great things. But then which mother wouldn't tell their child that, right? So in 1993, I decided to study medicine. So I went to the UK and I went to one of the oldest medical school called St. Bartholomew's Hospital in London. And I think this is where inspiration comes from. I think to be a doctor, if for those who are interested to be, clinicians, you can think about some of these characters from knowledge, expertise to compassion, empathy, as well as to interpersonal and team skill work. But the second lesson I've learned throughout my medical career is sometimes one yes can open new doors. You just have to be prepared for the opportunity. Because in the early 20s, I ended up in a hospital called St. Mark's Hospital. This hospital is the only one that specialized in the gut, essentially from all your mouth all the way down to your anus. This is a hospital. If you have any problem to do with your Chung, you just go there. And there I met my mentor, Professor Michael Carmen, a world-class gastroenterologist. And one day I was in the corridor and he said to me, Sue, do you want to do a PhD? And I was thinking it's very hard to say no to him, although at that time, initially, I just wanted to be a doctor. I never thought about doing science. But because of that one yes, I said, okay. He then referred me to this world-class immunologist, Stella Knight, who spent 40 years of her life studying just one cell in the human body. This cell actually is a dendritic cell, and it got the Nobel Prize in 2011. So I spent 3 years, my PhD, understanding this cell in the middle. It's called the dendritic cell. They call it the conductor of the immune orchestra. It actually governs your immune system to see if you get sick or if you remained well. And I always thought back, what was my life as a scientist working in the lab? I was facing the flow cytometer in the sort of machine. In the daytime, I would take samples from a patient. At night, I will be in front of the machine working until about sort of midnight. Then there was one time, my first taste as a clinician scientist was quite inspiring. I was so excited because I saw this cell, a dendritic cell, that was sticking its arm into the lumen of the gut, trying to sample bacteria. And in this patient, we now know we can perhaps use certain ways to treat a patient with inflammation in the gut in a 20-year-old man. And this will come back to my research interest later on. So imagine inside the gut, you can see the dendritic cell and immune cell trying to capture all these pathogens or bacteria. It's like when we're young, you're playing Pac-Man, and if it captures the right bacteria, it may influence a right immune system and you don't get sick. So in my mind, I think people and place are very important. You need to think, do the people inspire you? Do they have a track record? Do this place provide you with the opportunities you deserve? Does it foster the skills you don't have? And can you see yourself flourish in this place? It may not be the first, it may not be your last stop. So I got my PhD from Imperial College in 2009. And at that time, all I wanted to do is stay in England and then continue to be a consultant and a scientist. But for those of you who watch this movie, Forrest Gump said, Mama always said, life was like a box of chocolates. You never know what you're going to get. something else happened in my lifetime. In 2003, I think many of the students were not born yet at that time. A tragic hit Hong Kong, and that was the first SARS accident. This is the Prince of Wales Hospital. Many people died, many of my colleagues died. There I actually met, I was in England, and there was a broadcast of a scenario from the Prince of Wales Hospital. That very person was Professor Joseph Sung. He actually was a SARS hero. He broadcast and show us that, look, there's a dirty team and there's a clean team. I'm the dirty team. I never know next time when I'll be the culprit or the victim, because we don't really know much about the virus at that time. And I thought, wow, this is really, really sort of inspiring. So with a lot of chance, serendipity, I end up enjoying the Faculty of Medicine at the Chinese University of Hong Kong in 2010. So at that time, I wanted to do research on inflammatory bowel disease. Inflammatory bowel disease is a Western disease, actually. It's not happening in Asia yet. Not many people see it. We don't really know what causes it. Then Professor Song told me inflammatory bowel disease, when I was a medical student, we don't see it in Hong Kong. How are you going to study about this condition? So I think selecting a research field needs to suit your timing and suit you. And I think an area you pick is important if it's a common problem, if it's emerging, if it has severe consequences, if it will change clinical practice, if it can be translated to the patient, to your home. If it's not too competitive, ideally, you might have first move advantage. So when I first thought I wanted to study this condition, we don't see it in Hong Kong. Then I went to Shanghai probably about, 20 years ago, and I was struck by what I see. You look at the amount of fast food that is happening, processed food there is not how it used to be. So everyone was studying the genetics of this disease at that time because they think it may be the genetic change that caused this condition to be more common. But I was thinking, for a new disease to appear in a new society, our DNA does not change in 10 years, 20 years. It takes, centuries to change. It must be something else happening in the environment to our bacteria, the nurture part that may cause the disease to increase. So I then went to Wuhan to study. Actually, Wuhan was not as famous as it is now after what happened with the pandemic. And we described in Wuhan the first prospective study to document that this Western disease is now coming to China, to Asia. We are seeing more and more of it in young people. So when Nature sort of interviewed me, I said, look, there's so many cases of inflammatory bowel disease, we could really hardly keep up with the number of cases. They are exploding. So we called this the inflammatory bowel disease tsunami. And we then asked, how do we transit from just a few cases in the West now to the second wave we are seeing in Asia, which is escalating rapidly? So I thought, look, I wanted to go to rural areas of China where the condition is still quite rare and then compare with people living in mega cities, what's different in their lifestyle, in their diet, in their microbiome that may actually lead to this change. So in 2010, as a one-man band, nobody really studying the microbiome at that time. I then took a team and visited up to about 19 countries and regions, basically. And we formed one of the largest consortium to try to study this condition. So I think unity is important and bigger groups are really, really important. Because of that, foundations in the United States actually, for the first time, started to fund our research at the Chinese University of Hong Kong. And they funded 3 projects. And this is the first time a United States foundation actually gave us money to look into a newly emerging disease. So recently, at the Chinese Institute of Hong Kong, we started a global physician stream program. It's about a decade now, and want to bring up the next generation of clinician scientists, clinician leaders, and clinician engineers. I think for the students, it's actually fantastic that there are now a lot of opportunities to think about expanding your global network as well as scientific discovery journey. Then back to my interest. You may remember I said when I was young, I loved to look at stars. So one day I was in the United States and I saw a professor say something very interesting. There are 100 billion stars in our galaxy, but there are 40 trillion microbes inside your body. For example, there are 30 trillion human cells, but there are 39 trillion microbial cells. So if I count the number of cells in your body, you're only 43% human. But if you think about maybe I don't care about cells, I'm more interested in the DNA of the human. We have 20,000 human genes, but we have 20 million microbial genes. If I look at your DNA, you are only 1% human. The 99% of your DNA belongs to your 微生态, your microbiome. And this 99% are the ones you can change. You can't change the 1% DNA that your parents give you or inherit, but the rest of them you can. So this is a new frontier. We are moving from our DNA to our other genome. And now we know changes in your microbiome are related to many diseases, cancer, dementia, obesity, chronic pain, COVID, even eczema as well. So I started building a network to tackle these 40 trillions of bacteria, viruses, yeast, fungi inside the human gut. This is a pair of twins, identical. One is obese and one is thin. Just think about it. Their DNA should be the same. But when I look into the microbiome, they're very different. If I take the stool from a fat twin, basically, and put into the mice become obese. If I take the microbiome from a lean twin and put it in the mice remain lean. So there's a lot of implications you can think about for potential treatment. Then in 2013, a very interesting landmark breakthrough came through. An old therapy becomes alive. It's called 粪便移植反病移植. This found that if you take the stool of someone and you put it into someone who is very sick, who has recurrent C. diff infection, they got better. Who invented fecal microbiota transplantation? A, B, C, D, E. Just have a think. It's actually the Chinese. It came from our Zhou. In those days, there's something called WANG, which is fecal soup that helped to treat food poisoning. So about 8 years ago, an 80-year-old man came to me very desperate. He had this condition in the gut that caused him to poo blood and have diarrhea. He cannot leave his house for 3 years. And he said, can you experiment this on me? So I took the stool from his son, who is 20 years healthy. I blend it. I'm sorry, after this, you're not going to drink chocolate milkshake or coffee frappuccino again. And we use this treatment through endoscopy into this sick 80-year-old man. 6 hours later, he called me and said, 醫生, I want to 同你鞠躬 because for the first time, I can see normal stool and I can leave the house. He's an artist. He's a book writer. He's now in his 80s. He does book exhibition. And he wrote me a poem. He said, 10年变血一变搞掂 10年变血一变搞掂 which means basically, he's been having blood in the stool for so long. So this is the gut of what it looks like, very, very ulcerated. And after the treatment, you can see it got much better, completely nice and new now. So in 2019, together with the chief executive, with the ITC Shing-Tung, we were very honored to receive and build the first Center Magic that works in microbiome. And we are very thankful to the ITB for giving this opportunity. Then together with my co-founder, Professor Francis Chan, in 2010, we thought, why don't we open a company so that the discovery we make can become more impactful? So we wrote our business proposal actually on a piece of napkin at that time. And we wanted initially to use this poo-poo soup and make it into a pill to actually treat different diseases. The investor asked us, what's your business model? Are you asking people to eat poo-poo to treat them? So our business was actually rejected at that time. And then suddenly, 2019 COVID came and I stopped my venture. I was working as a frontline doctor at the Prince of Wales Hospital. We see a lot of patients coming in very sick. But then I made an observation. A same age patient can be very sick with COVID. Another person can have no problems when they come in, even with COVID. So I thought it must be their immune system, must be their gut microbiome. So we started looking at what's the problem with these patients who are very sick, and we found certain bacteria that's missing in their gut. And at that time, YHSA already said, look, you can maybe change the microbiome to give probiotics to help these people. So very, very quickly, in just a couple of weeks, we published the first evidence that COVID-19 also has some change in their bacteria, and we can do something to actually help these people. So we developed SIM01. This is available in different parts of China as well as in Hong Kong to boost immunity. And we did 2 randomized controlled trials to help these people, to help boost their immunity, to reduce their complications from COVID-19. So to me, this is rewarding. This is scientific discovery to, for the first time, technology transfer. So now we have 2 biotech companies trying to translate some of this knowledge transfer. This is now being run in Guangzhou, in Beijing, in Hong Kong, Macau, and different parts of the world. We now have a stool test that can detect polyps before it becomes cancer, because this is important. Prevention is better than cure. We now work in the microbiome because we know it communicates with your brain. So we have a test in the stool that can detect children with 自闭症 autism, because many of these children are not diagnosed because there's no gold standard test. So here we can think about scientists going with early diagnostic using a stool test. This has got FDA breakthrough device designation as the first-in-class precision test for autism, and we hope to launch it in Hong Kong, different parts of China, and globally. So last but not least, in the last 1 minute, my clinician scientist entrepreneur journey. I was very, very privileged to get the Bank of China Science and Innovation Technology Award, and of course to be the first female clinician scientist to get the New Cornerstone by Tencent. New Cornerstone Foundation has supported a lot of my work, and of course the Hong Kong's Academy of Science. So in the last 30 seconds, recently someone asked me, what do you want to do now? You've done so much. I'm interested in aging, the science behind aging. We now know the secret to a super long life may lie in your microbiome. This is a 100-year-old Japanese lady. When you look into her microbiome, you find distinct microbiome that can produce unique bile acids that help her stay so fit and so well. So people are banking blood. Why not bank stool? Because your stool, when you're still healthy now, later may help you later in life. So we are building a microbiomes vault in the Greater Bay Area so that we can collect, preserve, as well as help people when they need it. So last but not least, to churn poo-poo, become bugs, and become drugs, and to do tailored medicine for these individuals. So these will be a tailored microbiome pill that can help different kinds of diseases. And lastly, also a smart toilet. We're going to, people hate collecting stool, collecting poo-poo because it's messy. So in the future, we are working with engineers. You can sit in the comfort of your home. It can actually monitor your gut health and tell you your risk of different diseases. So to complete why I chose this path, because I get to meet amazing people from different parts of the world. I get to be in the stimulus of cutting-edge science, and I have the opportunity to be creative and innovative in my practice. If you are interested to be a scientist, these are a few of the criteria I think it might be useful to think about when you carry on your scientific journey. This was when I shared in Shenzhen. I was inspired by the students. They asked intelligent questions. There were 10,000 of them sitting in the audience. And I think mingling with them helped me improve myself. I can be here today because I've seen further by standing on the shoulders of giants, and I want to thank my mentors. But all of these can only be possible. So I think we have to be grateful as scientists, be grounded. My mom didn't give me too much. She only gave me the one thing I need in life, education. So for me to go this far. So my last slide, my message to every one of you. Dream big, pursue your dream, innovate boldly, and don't be afraid to fail. And the next time you're in the toilet trying to flush away your stool, just think about this. This one sample may be the one that saved your life because there's some magic inside it. It's been an honor, and thank you very much for giving me this opportunity to share.
Thank you so much, Professor Ng, for that insightful sharing. So I think we should give a round of applause to our female scientists, phenomenal scientists. When they share their achievement, I couldn't help but notice that they must have sacrificed a lot of their important things in their life, like time to sleep and time to have fun along the way, all in hope to make the world better. So their dedication and perseverance are truly inspiring. Thank you so much again. And now let's give the stage to our students, Terry, Simon, Michael from the ISS Academy 2025 Yale Prize Physics Silver winning team to share their experience in the competition. Terry, Simon, Michael, please.
Thank you, Carmen. Can you see my share screen?
Yes.
Okay. Hi, everyone. Thank you so much for having me today. My name is Simon, and joining me are my two teammates, Terry and Michael, and we're the silver winning team in the physics division in the last STL High School Science Award Asia. And it is truly an honor to be invited back as a speaker for this online science talk. When we first started our project, we never imagined how this would lead us to a medal, a journey to Tsinghua University, and now to have the chance to share our journey with so many talented scientists and enthusiasts across Asia. This feels incredibly special. And today I'd like to take you behind the scene of our journey in the Research Award, how the idea first came about, the challenges we faced, what we learned from together as a team, and some of the key lessons that helped us to turn curiosity into a complete research project. And I hope our story can inspire some of you as you prepare for your own entries or simply just explore your passion for science. So let's get started. So how this whole project actually started? It was an incredibly small observation, almost comical from hindsight. So in an ordinary school day, my teammate Terry accidentally spilled water onto his school uniform, and the water soaked into the fabric. We noticed something we've seen 1,000 times. The wet spots looked noticeably darker than the surrounding dry area. And the contrast was really striking. The dry area stayed bright, but the soaked area has a deeper shade. At first, it just seemed like a ordinary everyday thing. Who hasn't spilled water onto their clothes and watched the color change? Most people would stop, dab it dry, and move on. But that day we paused. We asked ourselves, why does that happen? What physics is really behind that simple observations that so many of us just pass and forget? And that curiosity sparked everything. We started digging into the existing studies and literatures for the so-called the wet dark problem, the phenomenon where porous materials like fabric, paper appears darker when wet. And we found plenty of current theories explaining it through optics, such as total internal reflections, scatterings. But however, the basic mechanism is widely understood and explained, but there were still open questions, especially about the exact scope and limitations of these theories and models when applied to real-life situations, such as the fabric of the clothes. that surprisingly has rarely been modeled. And thus we believe that this will be a great entry point, not inventing the wheel, but revising and testing the theories in a practical and accessible way. So it then became our research project of the revise and research of the scope of the wet dot problem. And from there, the real journey begins. A lot of experiments, simulations, and late night discussions, And I believe my teammate Terry has some technical issue with his Zoom account, so I'll proceed to cover his part. So then we basically identified that the current theories has some limitations that could not be applied to real-life examples. So we believe that we could try to integrate the current theories and build up the strength while try to reduce the limitations, and so that it could be realistically used. So we basically combined the three parts of optics theories and came out just a rough final equation. And however, we still identified that there is some huge limitations after this integration. There are oversimplified geometry, simplified physical process, and extreme difficulties in actually obtaining the parameters. And so we decided to reflect on this process and try to think about what could be done next. What would be a better way to solve this problem and make it a actually applicable process and theory. And so through some further research and a lot of discussions between teammates, we later introduced some other theorems to more accurately to depict the phenomenon and get a final result. But after experiments, I believe reflections is always a crucial thing to do. And through reflections, and there we still identify various limitations that could be found after this, although more accurate results. There is high cost and the difficulties to access to parameters and stuff. But after all, it is really a great experiment. Although there are still identified limitations of the final results, but we have already proceeded into a better place from the original studies and current theories that has far less accurate and unrealistic assumptions. And then one more thing will be the further improvement. After reflections, the reflections could always lead to further improvements. And although due to time limits, we couldn't really proceed any further in the competitions, but identifying improvements would definitely help you to support your future science research and modeling process. And of course, the applications. But finally, let's talk about our journey in the competition itself. Walking into the room for the oral defense, it's really heart pounding, facing the judge panel. And those professors are some of the most outstanding scientists in Asia. They're true experts. And as high school students, we were definitely really scared standing in front of them. But here's something quite counterintuitively that we discovered. They were actually incredibly supportive of our ideas. They understand that high school research isn't going to be perfect. They know that we're still learning about scientific modeling and experimentations. Yes, they ask critical questions, the sharp ones that make us think hard. But those questions were surprisingly inspiring. They actually sparked new ideas that we haven't thought anywhere, highlighted angles that we hadn't reflected on before, and gave us a multi-skilled expert perspective on our own work. And in the end, it wasn't an evaluation. It's just a tremendous learning and improvement opportunity. And facing those challenges head on, what kind of rigorous feedback pushes us to grow in ways we never expect. So then I'll invite my teammate Michael to talk about his experience in the YHSA Science Award Asia. Thank you.
Right. Good morning, or good afternoon, everyone. It's an absolute honor to stand here today. I'm Michael, and looking back on our journey from the STL High School Science Award, it feels like only yesterday that my team and I were standing at a blank screen, wondering how to turn a complex physical phenomenon into a structured research paper. To have walked away with a Continental silver medal was a milestone for us, but the growth we experienced behind the scenes and the people we met along the way was the real prize. I'll be honest, the early stages were not smooth. When we were creating our first draft and initial presentations, we hit two major walls: time management and team coordination. In the beginning, we worked individually. We had brilliant ideas, but no unified direction, leading to fragmented first drafts. And we realized quickly that working hard wasn't enough. We had to work together. So how do we solve those two problems? First, we began holding regular meetings twice a week to share current progress and discuss the next steps for our further meetings. And also, we devised a shared timeline planning document. This ensured every simulation and the slide was accounted for. So here's an advice for the younger generation. So keep a rigorous track of your time and progress. Research is unpredictable. Do not wait until the last minute to make corrections. Start your revising and correcting process early so you have room for the unexpected. All right. Now, when we entered the continental round and presented to the panel, the judges discovered a significant flaw. More specifically, we had not accounted for the thin film interference effects in our theoretical framework. At first, it was daunting to hear our theory was incomplete. However, this is the beauty of the SEL competition. We immediately integrated the interference effects, and this refinement drastically improved our accuracy. This taught us that scientific research is a continuous cycle of discovery and refinement. Whether it's through your own checks, your teammates, or the judges' expert comments, every problem discovered is an opportunity for a better version of your work. Beyond the physics, one of the most rewarding aspects of this prestigious competition is the community. During the global finals at the Tsinghua University, we had the unique chance to get to know and learn from other excellent scholars and students who share the same passion for physics. Seeing the diverse ways other teams approach their problems was incredibly eye-opening and inspiring. Lastly, I want to extend my deep gratitude to Professor Shing-Tung Yao, SDL competition officials, as well as the volunteers engaged in this activity. Thank you for providing us with a platform that regards high school students like professional researchers. To the judges, thank you for your helpful comments. You didn't just grade us, you mentored us. To the future participants, lean on your teammates, learn on your teammates, and embrace the feedback. The STL competition doesn't just teach you physics, it teaches you how to be part of the global scientific community. Thank you.
Okay. Thank you, Terry, Simon, Michael. So I just want to say that students, you're absolutely amazing. And it's really enjoyable to listen to your journeys from your initial observations to designing experiments, to the heart-pounding experience during interviews with world-class scientists. We all went through that. And the future is yours. I can't wait to see all of the incredible things that you will achieve. Now, last but not least, we will invite Professor Yao Xing-Tung, the founder of the STL High School Science Award. Nothing is possible without Professor Yao, so he's going to give a closing remark for the science topic today. Professor Yao, please.
Yeah, thank you. I'm really excited to listen to all these very inspiring talks. First of all, I am very grateful to the National Academy by Hong Kong, Hong Kong Academy of Science. They have been supporting this event for so long, and I'm very happy to see that it's doing very well. In fact, it's getting better and better in the last few years. This is the Asian session that are competing among themselves. later, the winners were sent to Beijing to compete. In these last few years, I think we are seeing some better performance across the whole sector of Asia, comparing with America and also the Chinese performance. We have this team in physics, which I think is really very good, which you listen to, and I'm very happy to see their performance to be recognized. I'm also very grateful to the Hong Kong government led by Shing-Tung, and he is supporting our performance and our activities for promoting science and technology in Hong Kong. I have to say that we have many great products of Hong Kong science and technology in the last 60 or 70 years. I grew up in Hong Kong myself. I was in Hong Kong from 1950, 1949 in fact, all the way to 1969 for 20 years. I'm always very proud of being a Hong Kong citizen, and I have been watching many of my friends and many of our Hong Kong residents or citizens who grew up in Hong Kong who has performed excellent jobs in science and technology, as witnessed by Professor KWAN and Professor WONG, whose speech is inspiring, truly inspiring, and I learned a lot from the two speeches, and I was amazed that the stones are so important for our life, and I have to learn more. My son was actually an expert on that too, I guess, but he never mentioned that to me. Anyway, I should say that the glorious days in Hong Kong actually was in the 1950s, 1960s, where we produced the very best scientists in the world, including Nobel laureate like Tracy, who graduated from my high school, Peijing Middle School. And in fact, just in my middle school alone, Peijing, we have 3 alums who were awarded the National Medal of Science and Technology in America, and about 6 members of the National Academy of Science in America. This is a rather remarkable records, and I think, there are many others truly established scientists, including our President Lu Yumin himself. And these are all great scientists and engineers, and I would hope to recover all these established in the modern days. We are competing with many more people in the world. Even in China itself, I think the mainland Chinese are teaching their children in a very effective manner. I've seen many really first-class, outstanding students, and young and good and creative and with passion. The one thing I'm proud of Hong Kong students is that they're full of energy, passion, and really want to create something, as witnessed by 2 of our speakers, and they're full of energy and want to do something great. And I hope our Hong Kong students also will be full of passion and try to establish something that will last for a long time in the history of science and technology. And I hope our students have this ambition. And this competition is a means to help you to charge on, to compare yourself with the whole world, not just among people in Hong Kong, but compare with people in America, in Europe, in Asia, and in mainland China, to see how good you are. Because we could do it. In fact, as I mentioned, many of our Hong Kong scientists has led the world for a long time. And I hope some of our students who will get an award here will remember that. You may not win the big award. That doesn't really matter, because you learn something. And I think this will teach you a way to do research. And in fact, when I was young, I never got any awards until when I was 28. I started to get some awards. So don't worry that you don't get awards. yet, but you will charge on and with passion for science and technology. I wish Hong Kong will be the leading city in the whole world to lead science and technology. Thank you for all of you, for all the people who helped this event. Thank you.
Thank you, Professor Yao. So this is the end of the science talk. So I very much echo with Professor Ng that it's by standing on the shoulder of the giants we can see further. And we hope to follow your legacy. Professor Yao, thank you so much.
Thank
And at
you.
this time, I'd like to thank all the speakers, Professor KWAN, Professor Ng, and the students for the time and sharing of their experience in the path of scientific discovery. And I hope all the students enjoyed the event today and stay tuned to our website and social media for the news of the Yao Prize Asia. And I hope everyone would have a good weekend before you chase your dreams next week. And see you next time. Have a good weekend. Bye, everyone.